Okay, what we've got here is the influence of directed airflow on combustion in a spark ignition engine. Again, this is probably an earlier version of that one I showed you on the other video where they were experimenting with directed flow into a combustion chamber. Kind of curious if I can get to the end of this, what conclusions they came up with. If my voice will hold out that long. I'll set this down until I get to the right page. Okay, conclusions. Excellent cyclic reproducibility was obtained by directing the air so that swirl moved past the spark plug when it was in a plane normal to the axis of the cylinder. Doubling engine speed without increasing linear velocity of the inlet air caused an increase in the rate of combustion of the same magnitude as that caused by doubling the inlet air velocity without increasing engine speed. When the valves were shrouded so that the inlet air velocity was doubled and were set to cause a directed air swirl, the rate of burning was increased. When the valves were shrouded so that the inlet air velocity was doubled but were set so that there was no direct swirl, the rate of burning was not necessarily increased. I'm trying to read this through the viewfinder, that's why I'm kind of stumbling over this. I can't quite see it very well. And then the references. This is really interesting. You can go here and you can find other NACA documents where they were talking about that. The interesting thing is when I get to the SAE documents that I have, they're set up almost the identical way as what the old NACA documents were. Let's see what else we got. Fuels for high compression engines. This would have been in the 1920s. And this gentleman, Stanwood W. Sparrow, back then did a lot of really good research. You never hear of him for some reason anymore. And he kind of disappeared from these, by the late 20s, early 30s. I don't know if he was maybe older and then either retired or passed away, or I'm not sure. Okay, effective fuel inlet of fuel-air ratio, inlet temperature, and exhaust pressure on detonation by E.S. Taylor. Now, that was the brother of Charles Fayette Taylor of that two-volume set of internal combustion engines that I showed you in an earlier video. A lot of good information there. Okay, correlation of cylinder head temperatures and coolant heat rejections of a multi-cylinder liquid-cooled engine of 1,710 cubic inch displacement. Okay, here's from 1948 talking about air entrainment and effective local boiling and air entrainment on temperatures of liquid-cooled engines. On laminar and turbulent friction. This was another German work from 1921. That would have still been during the Weimar Republic. Notice they must have pulled this, I would assume, out of the Third Reich whenever we were over there getting information, because see the date on that's 1946. So they must have found this over there, and of course they converted it over to English. Steady and intermittent flow coefficients of poppet intake valves. That was 1946 as well. Okay, and then here's a really good one. I've looked at this one over several times. Effective changing manifold pressure, exhaust pressure, and valve time on the air capacity and output of a four-stroke engine operated with inlet valves of various diameters and lifts. This was actually a very good one from 1947, and you see that work was done at the Massachusetts Institute of Technology. Let's see what else we got here. Okay, this one here, NACA report 1926. It's one great big huge report. NACA investigation of fuel performance in piston type engines. Have several different chapters on that. I'm not going to read them all out. My voice is about ready to go, but hold it on there long enough you can read it. There's a very interesting one there. I've read that over many times. Tetraethyl lead is still probably the best anti-knock, although it'll kill you eventually if you work with it too much. Internal cooling. Okay, what is internal cooling? Well, believe it or not, in the 1930s, they were experimenting with water injection for two reasons. Number one, for knock limiting, and also number two, for increasing fuel mileage. Basically, they were leaning the mixture as much as possible, and then they actually experimented with quite a few different substances. They found the ones that they found seemed to work the best was a mixture of water and some of the amines. If I remember right, I'll see if I can find it here. This camera down again. Yeah, I found that the aliphatic amines were probably some of the best. Monomethylamine, ethyleneamine, dimethylamine, trimethyl-butylamine. They were actually some of the best internal coolant additives, mixing them with water. So, pretty amazing some of the work they were doing back then, from the 1920s up to the 1940s. 1950s. Okay, so the next stuff I've got up here are some of the SAE documents, and since my voice is going, I'll just hold it on there and show you some of the names on some of these. That happens to be a very good one right there. But this is the sort of thing that when I see something like this, I purchase it. The NACA documents are on there. Most of them, when I downloaded them in the early 2000s, were all free. I guess they charge for some of them now. I'm glad I downloaded them when I did. But the SAE documents, you have to pay for all of them, and there's a lot of restrictions on them. You can't share them or anything like that. So basically I'm just going to show you the title page, give you an idea of some of the ones that are out there. All very good information. Okay, got another one here. These are just the ones I've printed out. I've got literally, between the SAE documents and the NACA documents, I've got literally thousands of these things. Yes, sir, SAE documents I don't have thousands since I have to pay for them, but definitely NACA documents I do. As you can see, this is all, if you're building an engine, designing a setup, this is all information that would be really good to have. This is a very good one as well, if you're looking to get one. And this one here was some of the design process they used for the cylinder heads in the Hemi. And what's kind of interesting is, if you look at some of what they did to optimize tumble in the new in 2002 Chrysler Hemi, it was very similar to what they were using in some of those NACA documents that I showed you earlier. Yeah, this is another very good one right here. This one here also very good. Shows a process they go through for optimizing exhaust header length and diameter. And I think they talk about the different collector configurations. I'm probably really not allowed to show that to you. They give you a lot of restrictions on these. I'm not supposed to copy this and pass them out or anything like that, so I probably better not show the text, but definitely good information. And I've got a whole other huge folder of it here of either SAE documents or NACA documents. Probably not going to bore you with much more of this, but this is the sort of thing, if you actually want to, yeah, there's another very good one. If you actually want to know what is going on in the internal combustion engine and actually build something worthwhile, this is stuff you need to know. Yeah, there's another very good one right there. That one there's a course on corrosion I found. I was using that to learn a little bit more about it for work. This here is a continuation on the one about the internal cooling. So basically about some of the different mixtures for fuel injection. Let's see if that'll read a little bit of the summary there. I'm hoping that focuses it on it well enough. And anyways, I could go on and on about this, but just showing you some of the information that I've read and gone through. Probably, I don't know how many parts this is going to be, 4 or 5 really long parts. Probably this one here is getting over 13 minutes, but I don't know if I bored everybody totally to death, or maybe this is something interesting to at least 1 or 2 people. If it is, then it was well worth it. So I probably ought to just give it up now. So that'll be it.